Okay, so this is the next video, and this is on 1.2, which is called Attributes of Functions. This is a one-day lesson only, and on 1.2.2, for the following linear function, find the domain, range, and intercepts. Then find the minimum and maximum values, write the domain and range in interval notation. So it's asking for several things. Over to the side, the function they gave you was 4x plus 9 with the boundary from -2 to 0. And the first thing you do is figure out the domain. It's a linear function. In other words, it has x, it doesn't have x squared, it doesn't have divide by x or the square root of x, and so that would be -infinity to infinity. So anytime you do that, it's like this: 4x plus 9. It's just a slanted line. The y-intercept up here is 9, and if it were regular steepness, it would be like this, but it's a 4, so it's steeper. So your domain has no limitations. It's -infinity to infinity, and your range is also -infinity to infinity. So that's going to be very standard. Anytime it's a linear function, anytime it's linear, you're going to have that set. It may be worded like all real numbers for both, but it's also -infinity to infinity. Okay, the next part is they're asking you about the x-intercept. So the best way to get the x-intercept is to take your function, which was the 4x plus 9, and to set that equal to 0. And then you solve. So you move the 9 over, so it's -9. You divide by 4, so you get -9/4. And it crosses the x-axis when it's an x-intercept, so it'd be x comma 0, and in this case it'd be -9/4 comma 0. And so it does exist, and it's -9/4 0. The next part is getting the y-intercept, and that's where it crosses the y-axis, 0 comma y. So basically you're plugging in 0 for x. So you go 4 times 0 plus 9, which is 9, and you get 0, 9. So again, that does exist. Now, the minimum part would be the smallest y value between -2 and 0. And so when we look at this, let me get rid of that second function. Okay, so when we look at this, setting our window, menu 4 is window, settings, we want to change it from -2 to 0. And so we're going to be from here to there basically. And if you look in your table, at -2 you get 1, and at 0 you get 9. It's the same thing I got when I worked it out by hand. F of -2 would be 4 times -2 is -8, plus 9 is 1, and when you put a 0 in for x, you just get 9. So the minimum would be 1 on the interval -2 to 0, and the maximum would be 9. So that's how you do that problem. There's no absolute maximum. In other words, if you didn't limit it from -2 to 0, it would keep on going forever and not have a particular number that it's the lowest or tallest. So you're just given that interval, and so that's what you use. Now another thing is if this were a negative sign in front, you'd probably have to switch your minimums and maximums. So make sure you work out all the problems. But for this one, it was positive slope, so it's slanting up. So the lowest would be on the left, and the highest would be on the right. Okay, so that's for that problem. The next problem is 1, 2, 4, so section 1, 2, number 4, and it tells you f of x is negative 16, and your interval is from 0 to 20. So notice they don't say negative 16x, they just say negative 16. And so if this is your x-axis and this is your y-axis, this would be f of x equal negative 16, which is basically a horizontal line. And so your domain would be, all real numbers, which is your negative infinity to infinity. Now your range can't be all real numbers because it's not defined here, there, anywhere except for negative 16. So your range is only negative 16. And this does not have an x-intercept because it doesn't cross the x-axis. It does have a y-intercept right here, and it's 0, negative 16. And the minimum and maximum are also both negative 16. So that's what you do when it's a whole number, or a constant, as we say. All right, the next one says find the domain, range, and intercepts. And then the minimum and maximum on 0, 2, and in this case you're given a graph which looks like this. So if it's linear, your domain and range will be your negative infinity to infinity for both. On Math Excel, you're going to want to use the pop-out graph, so you just click it and it enlarges. And the graph goes through 0, 3, and 2, 6. So what I did was I used those 2 points to find my slope. I do y2 minus y1 over x2 minus x1. And so that'd be 6 minus 3 over 2 minus 0. So that gives you 3/2. So that's how we find our slope. So it's rising 3 and running 2. Now, because we already have the y-intercept, which is 0, 3, we're going to use our slope-intercept form. Y equal mx plus b, and so we have y equal 3/2 x plus 3. So that's your equation. Now, that wouldn't be an answer, but you need to know how to do that in order to get your x-intercept and your y-intercept. Well, your y-intercept's easy, it's just 0, 3. But to find your x-intercept, you're going to have to set this part equal to 0. Because basically, we're thinking it's x comma 0, and so you basically set y equal to 0. You change this y to be 0. And then you can divide by 3/2. Make sure you use parentheses for that. And it's going to look like this. Negative 3 divide by parentheses 3/2. And you get negative 2. So that means negative 2, 0 would be it. And again, as we said before, your y-intercept would be 0, 3. It's always 0 comma a number for your y-intercept. Now for your minimum on that interval, in this case, if your interval starts here, then 3 is your lowest point. And if 2 is here, then 6 would be your maximum. We already said it went through 0, 3, and 2, 6. But this is the calculation of it. There's one other thing I wanted to show y'all. If you're working this through the calculator, let's see, 3/2 x plus 3. Okay, so you can double click this, make that 0, and make this one 2. So you can manipulate your graph if you need to, your window. There are different features on here that's pretty good, like analyze graph, and you have your minimum and maximum, and then some other advanced stuff. So if it's just a linear function, I don't even bother using the minimum. In other words, I would just use that for if it's a parabola, so like a curved one. So I don't even use this part for when it's linear. Alright, so that's 1, 2, 5. Now the next one is 1, 2, 7, and it says the linear function d of t equal 4 minus 3t gives your distance d in miles from home t hours after you leave the library. And part A says sketch the graph and write the domain and range and inequalities. And part B says what are the intercepts and explain your meaning. So to begin with, they gave you the function d of t is 4 minus 3t. And think of that d of t as the same thing as f of x. It doesn't mean f times x, it's just function notation. It's one of your vocabulary terms. So when you put this in your calculator, you would put f of x equal 4 minus 3x. You'd have to use x, not t. So that's one little thing. But then you'd have a little table with 0, 4, and 1, 1. So this one's slanting down. And so your y-intercept would be 0, 4. To find your x-intercept, set your equation equal to 0, and you get negative 3t equal negative 4 from bringing that over. Then you divide negative 4 divided by negative 3, which is positive 4/3. So t is 4/3. And so you get 4/3, 0. Now, if you were doing this one on the calculator, we have 4 minus 3x, and it's a little bit past 1, but you can't say for sure, like is it 1.5, is it 1 1/3, whatever. So you could go to menu, analyze, 0. Now 0 of the graph is the same as the x-intercept. And so you could go 0, and then it says lower bound, which means left side. So now I'm on the left, now I'm on the right. And it says 1.3 repeat, which is 4/3. So that's how you would use it on the calculator. I still prefer by hand, but that's the other way to do it, because this has it as a fraction. You'd have to like go back to this screen if you didn't know what the fraction was and put a bunch of 3's in to like halfway where the screen is, and then go menu, number, approximate to fraction, and that's where you get 4/3. Just ignore the 5e to the negative 14. That's just a number really close to 0, so just ignore that part. But this, as a fraction, is 4/3. So that's how you can get it. So now, thinking logically, can we have negative time? No, we're not going to say it's 10 seconds or 10 minutes before something happened. So we're going to start our time at 0, like and hit the stopwatch, so to speak. And it's going from 0 to 4/3. Now for your range, you'd be going from 0 miles where you start, like where you are, to 4. So 0 to 4 miles. And so your x-intercept would be 4/3 0, and your y-intercept would be 0, 4. Now, the y-intercept in this problem means the distance, and so that's 4 miles. And the x-intercept in this one means the time, which is 4/3. I remember when I worked this Math Excel, it gave you an option of putting x-intercept or y-intercept. So make sure you know the meaning of it. The y-intercept in this case means distance, and that's the 4. So where it crosses the y-axis is right there, where it crosses the x-axis is right there. Okay, so that's 1, 2, 7. Okay, then the next one we have is 1, 2, 9, and that's f of x equal x cubed plus 8. So what this is you have your plus 8 to the outside, and so it means it's shifted up 8 units compared to x cubed. So if we have x cubed, x up arrow 3, it would look like that. And if you do x up arrow 3, then you have to go to the right and then plus 8. Then that just means it's shifted up, and I'd have to move this, I'm just going to guess 50 for it to be visible. Okay, well, it's not letting me double click that easily, so this is a good opportunity to just say menu and then window, settings, and I'm going to make this y max is 50. So now you can see it's the same graph, just shifted up 8. So this is our first cubic function. It's not quadratic, it's not linear, it's cubic, means to the 3rd power. But again, there's no vertical asymptote, there's no holes in the graph, there's no undefined spots. It's continuous. And so there would be no change from this domain to that one. And same thing on the range. Now for your x-intercept, there would be a difference. And I just wanted to point out, if you go Control T, here's your x value, here's your x cubed that's blue, and I went to the right, here's your x cubed plus 8. So let's see, -2, -8 goes together, and -2, 0 goes together. So just remember, you can move left and right. Your x stays there, but then if you have more than one function, you can go back and forth as needed. So you just click in there and then go left and right. Okay, so your x-intercept changes from 0, 0 to -2, 0. Okay, how do we know that? Well, we know from basically the blue graph going through the ordered pair 0, 0. Okay, that just makes sense. If x is 0, 0 cubed is also 0. And so you know on your original, both of them are 0, 0. Then for your other one, we can do open up the table and you saw it was -2, 0, or you can go to Analyze Graph, 0 the graph. First it's asking, well, which graph do you mean? Do you mean the blue one or the red one? And so I have to click the red one. Okay, and then lower bound means left side, and upper bound means right side. And remember, you can, if it's an open hand, you can push and move it. So there's your, and then drop it. you have your -2, 0 is your x-intercept. So it's a little bit further to the left. And then as far as your y-intercept, the easiest way is to just go to your table. And when x was 0, y was 8 for F2. Or you could just think 0 cubed plus 8, and that's how you get it. Again, it's algebra. Whenever it's algebra, there's multiple ways to do it. The other way was do your x cubed plus 8 equal to 0, so x cubed is -8, and then you do what we call cube root of 8. I'm sorry, -8, cube root of -8. So that would be, if you go back to this and you go control up arrow is nth root, that's where you can put a 3 there for cube root, and then you put -8 here, and then you get -2. So in other words, that's equivalent to -2 times -2 times -2. It's -8. So that's how all those are related. Okay, last problem. On 1-15, you have 4 over x compared to 1 over x, and it's talking about domain. Actually, there's 2 problems left. There's one problem where it says domain, and there's one problem where it says range. So these are what we call rational functions, where you have x in the denominator. And so 1 over x would be the inside one, and 4 over x would be the outside one. So let me show you how this works. 4 over x and 1 over x. Okay, so the 1 over x is inside, the 4 over x is outside. And then just like we did before, if you go Control T for your table, you'll be able to see the values for F1 and F2. And so that's what I wrote out here. When you're working your Math Excel, you may want to do the same thing. These were the 5 x values I used: -2, -1, 0, 1, 2. And then you can look at your table to see the numbers, and 4 divided by 0 would be undefined. That's where you would have a spot where it's not all real numbers if you're discussing your domain. And again, you could just say 4 divided by -2 is -2, 4 divided by -1 is -4. Okay, and so then the next part you'd have is, if it's 1 over x, that's 1 over -2 is -1/2, and so forth. So there's your table. And again, I just wrote out what it means. If you have a table like this with x, 4 over x, and 1 over x, your x goes with both. It's -2, -2, so basically ignore this one. And for F2, you ignore this one, so it's -2, -1/2. So that's how it works. So then, to choose the correct graph on multiple choice, make sure you look for the one that has a vertical asymptote at x equals 0, as well as a horizontal asymptote at y equals 0. So it doesn't cross those spots, since there's no intercepts. So it approaches those lines, but it doesn't go through them. On the domain, there would be no change, and so it's still basically from -infinity to 0. And again, this is a parentheses, not a bracket, so up to 0, but not exactly 0, union 0 infinity. So that's basically equivalent to the set of all x's such that x is not 0. So this is a union, which means the left side and the right side, or the right side, and then this is the set notation. And then what I noticed was sometimes when you do the recalculation, whatever, the 4 over x would change to 2 over x, and so forth, and you know. But then on 15, it's asking for the domain, and on 16, it's asking for the range. And on both, there are no change despite having a different number there. So your range would still be all y values except for 0. Okay, that's the end of that video. Have a good day.